The purpose of this hands-on laboratory and tutorial is to familiarize you with the use of a breadboard, also called a protoboard. This video will help you use the breadboard to build electrical and electronic circuits. As you watch this presentation, you can stop and go back to any part you wish to repeat. A breadboard is a reusable solderless device used to build a generally temporary prototype of an electronic circuit and for experimenting with circuit designs. A modern solderless breadboard consists of a perforated block of plastic with numerous tin-plated phosphor bronze spring clips under the perforations. Integrated circuit chips or ICs in dual N-line packages can be inserted to straddle the center line of the block. Interconnecting wires and the leads of discrete components such as capacitors, resistors, inductors, etc. can be inserted into the remaining free holes to complete the circuit topology. In this manner, a variety of electronic systems may be prototyped, from small circuits to circuits as complex as computers. The breadboard derives its name from an early form of point-to-point construction. In the early days of radio, experimenters would nail copper wire or terminal strips to a wooden board, often literally a board for cutting bread, and solder electronic components to them. Sometimes a paper schematic diagram was first glued to the board as a guide to placing terminals and components and wires on the board. The integrated circuit for the famous SX70 instant sonar camera, first introduced in 1972 by the Polaroid Corporation, was breadboarded before Texas Instruments fabricated the custom IC chip inside. It was rumored to have been built from discrete components on a 4-by-8-foot piece of plywood and was fully functional. The project was so secret that Texas Instruments engineers were only given functional specifications, but not told the purpose of the chip. A breadboard is designed to make it easy to build electrical circuits without soldering. These breadboards are often numbered on the sides to make it easier to figure out the placement of the parts. Some boards have grooves on either side of them, allowing you to interconnect several of them together. The breadboards have many strips of metal, usually copper, running underneath the board. These strips connect the holes on top of the board. This makes it easy to connect components together to build circuits. To use the breadboard, wires or electrical components are placed in the holes. The holes are made so that they will hold the component in place. Each hole is connected to one of the metal strips running underneath the board. The green stripes in this picture show the groups of 5 holes that are found on most breadboards or protoboards. They are electrically connected. The groups or strips of 5 holes are connected by spring clips under the holes. Wires pushed into any of the 5 holes will be connected. For example, these wires are connected, and these wires are connected. But these wires are not, because they are not poked into the same strip of holes. These wires are also not connected. Neither are these. So to make a connection, you must make sure the wires are poked into the same group of 5 holes. There is a channel or slot down the center of most breadboards. Here it is marked in yellow. The strips on either side of this channel are not connected. The wires in this picture are not connected. There are 5-hole strips on both the left side of the center channel and on the right side of the center channel. The strips on either side of the channel are not connected. That is why these wires are not connected. The purpose for the center channel is for mounting of integrated circuits or ICs on the breadboard. The integrated circuit can then be connected to other integrated circuits and other discrete components such as resistors, potentiometers, capacitors, diodes, and transistors. On most protoboards, there are long strips that are used for the power supply connections. Some boards have 2 strips on each side. These long strips, known as bus strips, run down one or both sides either as part of the main unit or as separate blocks that are clipped on to carry the power supply voltages. They are sometimes called power rails. This breadboard has two on each side with a red and blue stripe, red for positive and blue for negative. Some breadboards have the power strip split in the middle. A jumper wire can connect the two halves of the power strip if desired, or they can be used separately. The Electronics Learning Lab from Radio Shop has a breadboard on it. The top of this breadboard has a series of 6 5-hole long strips for power connections for plus 1.5, 3, 4.5, 6, 7.5, and 9 volts. The 6 AA batteries are connected in series or end-to-end to get the various voltages. The voltages are tapped as shown in this diagram. Along the bottom of the Radio Shack breadboard is a long strip for connection to the ground or negative of the battery bank. Here is a simple radio receiver circuit on a breadboard. Here is a close-up of part of the circuit. This picture has a 5-hole strip marked with a red box where a resistor, capacitor, and 2 other lead wires are connected. In this picture, the strip that is marked has 3 connections. One is red positive wire from the batteries. In this connection, the black negative wire from the batteries is connected to the emitter lead of a transistor and is also connected to 2 capacitors. In another circuit on a breadboard, you can see connections to the positive and negative power strips. To use a breadboard, you will need some jumper wires. A jumper wire assortment like this is convenient, but not necessary. You can also cut pieces of wire off a roll of 22 or 24 gauge hookup wire. A good and cheap source of hookup wire is twisted pair network wire such as Cat 5 or 6 Ethernet cable or telephone wire. To make jumpers you need a wire stripper. You will need to remove about 1/4 inch insulation off each end. For short jumper wires, this can be done in one operation by sliding the insulation. Please note, you should never try to put more than one wire or component lead in each hole. Doing so will damage the board. Also, you should never force a wire into a hole that is too large. If you need to connect something that is too large for the holes, first attach a proper size jumper wire to it. In the next part of this presentation, you will gain experience with a breadboard by building a circuit that uses a variety of components, including a wire, an integrated circuit, resistors, a capacitor, and a diode.